Hello friends, welcome back. Myself Dhruv Pathak. Today we are going to learn about the abnormal molar masses. Abnormal molar masses undergoes the dissociation and the association in the solution. Now dissociation takes place in the salt molecules, or you can say salt compounds, whereas the association takes place in the organic solvent. For examples, you can say benzene, or you can say benzoic acid, or you can say acetic acid. Now what makes the difference in the dissociation and association part over here? So in dissociation, whether it's acids known HCl, H2SO4 and acetic acid, inorganic bases known as NOH, KOH or CaOH whole twice. Whether it's a salts, any salt, NaCl, KCl, KNO3 or BaCl2, etc. Clear? Now what do you mean by this dissociation? Now all the molecules will either be dissociate completely or to a small extent. So what happens over here? Now as you can see that it dissociates completely or to a small extent. So what is remaining? So here the number of particles in the solution will increase. What will happen? It will increase. Increases. Clear? As we know that the colligative properties depends upon number of particles of solute. So here remember two words, one is experimentally observed value and theoretically expected value. So let us learn through the examples. The example which was taken earlier was KCl, K plus plus Cl minus. Now here you can see that there is a 1 mole of KCl and it is completely dissociated with K plus and Cl minus. So number of particles is doubled. You can see here is 1. So 1 plus 1 is 2. So number of particles in KCl will be what? Doubled. Whereas molecular mass of KCl with the combined and with the separate would become half of the expected value. Clear? So in the dissociation you need to remember that the number of particles is doubled, whereas molecular mass is the half of the expected value. What happens for the association? In the association, what happens when acetic acid combined with the benzene, it dissolves. That's true. As mentioned earlier, that association is dependent on the organic solvent. So here you can have, or you can see that when I take the 2 moles of acetic acid, you will form a 1 dimer molecules. Now what is it? What is it? It is that the oxygen and hydrogen, now they are what, combined with each other. So here they are associated. We can say these 2 molecules are associated with each other due to hydrogen bond. So number of particles, what happens, is decreased, and molecular mass would be higher than the expected value. Clear? So in the association we need to keep in mind that the particles is decreased, whereas molecular mass will be higher than the expected values. And in the association dissociation it was that the number of particles is doubled, whereas molecular mass is half of the expected values. So you can see that when the molecular mass of a substance determined by studying any of the colligative properties comes out to be different than the theoretical expected value, the substance is said to be the abnormal molecular masses. Is that clear, children? So keep in mind that the colligative properties means that relative lowering of vapor pressure, boiling or elevation in boiling point, depression in freezing point, and the osmotic pressure. So we are talking about this, all the 4 colligative properties depending on the theoretical expected values. So it is known as abnormal molar molecular masses. In 1880, Van 't Hoff introduced the I factor. Okay, introduce the I factors so that we can find the theoretical value upon experimental value. So I is known as Van 't Hoff factor. Now what is the I over here? The I indicates when I is less than 1. Suppose the value of I is less than 1 or unity, we say association. Or if if I is greater than 1, when the I has more than 1 value, we say it's an dissociation. So here whatever the values is been given, observed value would be less than 1. For example, if I have 1 gram of benzoic acid, that means the expected value would be, or I would be less than, it will be half, that means 0.5. In dissociation what happens, when I say I have 2 gram of KCl, it will be double, the molecular mass will be double, so I would be greater than 1. This is what we are expecting. Now let us see how this colligative, or you can say Van 't Hoff factor, has been modified in the 4 colligative properties. Number 1, relative lowering of vapor pressure would be equals to P0 minus PS upon P0, as we know that it was N2 upon N1 plus N2. Now what was N2? It is known as X2, that means mole fraction. So multiply with the I. This is how we can find the Van 't Hoff factors. Elevation of boiling point was delta TB is equals to multiply I with KB into M. In depression of freezing point, we write delta TF is equals to I multiply with the Kf into M, and osmotic pressure mentioned as a pi equals to I multiply C into R into T. T. Now through these characteristics we can find the numericals. In next session we'll move towards the numericals on the abnormal molar masses, and we can find out the association and dissociation form. That's for today. We'll meet on next lecture. Thank you and have a great day.